Hey everybody, welcome back to AP Calc AB. In this video we're going to go through a handful of integral problems now that you've been introduced to it, or reintroduced for that matter, and we'll come up or establish some basic rules for integrals. So let's go through a couple examples and do that. So let's start off with the integral. We'll do an indefinite integral, and just for the sake of the video we're not going to include it plus c, and you'll see why in just a little bit. It actually becomes relevant or irrelevant. But let's say we want to take the integral of 5x plus 6. What does that give us? Well, if you remember from the previous video, if you remember the power rule that comes with integrals, you'd probably come up with an answer that looks something like 5 times x squared over 2 plus 6 times x to the 1 over 1, which is equal to 5 halves x squared plus 6x. And that's right. Now, maybe for some of you who might have gotten stuck on it, if you take the derivative of this, if you derive this, if you were to use the other power rule, if you were to take the derivative of both these terms and then add them together, you end up getting, well, the x squared, 5 halves x squared becomes just 5x, plus, and the 6x becomes just 6. So as you can see, the integral of 5x plus 6 gets us 5 halves x squared plus 6x, and the derivative of 5 halves x squared plus 6x gets us back to 5x plus 6. So what can we conclude from this? We'll treat these as two different functions. So let's say we want to take the integral of f of x plus g of x. Well, this can be rewritten as the integral of f of x plus the integral of g of x. And we see that in work right here. Integral of 5x plus 6 can be rewritten as the integral of 5x plus the integral of 6. And if you were to apply the power rule of integrals to those individually, that's where you get 5 halves x squared plus 6x. So this is the first thing we want to establish. Let's move on to our second example. Let's say we have integral of x squared times 2x cubed. What is this going to be equal to? Okay, if you want to use the power rule again, we'll get x cubed over 3 times 2x to the 4th over 4th, which is just 1/3 x cubed times 1/2 x to the 4th. And we can simplify this and make this 1/6 x to the 7th. Okay. Well, let's go ahead and take the derivative of this, and what do we get? This gets us 7/6 x to the 6th. Okay. These two are clearly not the same thing. That means we did something wrong. Well, what is that? Here's the second thing I want to establish. The integral of, once again, we're going to treat these as two different functions. The integral of f of x times g of x is actually not equal to the integral of f of x times the integral of g of x. And we just saw that right here. So this is the second thing I want to establish. Then, what do we do if you want to take an integral like this? Well, it's pretty obvious. You saw that I did it right here, actually. We just combine like terms. So taking the proper integral, you want to combine your like terms. Well, x squared times x cubed is just x to the 5th. So you're going to get 2x to the 5th. Now, here's another tip for doing integrals. Whenever you see a constant like this, it's something that's not directly attached to the variable, like an exponent, you can bring that outside of the integral. So it's 2 times the integral of x to the 5th. Now, just note, let's scroll down just a little bit, that this also works with divisors. So if you want to take the integral of x to the 5, divide by 5, you can rewrite this as the integral of 1/5 times x to the 5th, and then take that 1/5 out and rewrite it like that. Now this becomes easier in some cases where you have a lot of coefficients and you really don't want to do the math. Like, maybe you have like 34x to the 247 and you want to take the integral of this. Well, you really don't want to have to worry about that 34 while doing the power rule. So you can just take that 34 out, do the integral of x to the 247, which is just x to the 248, which is x to the 248 over 248, and then you can reattach the 34 at the end. So it's a lot easier in cases like that, which is why this rule comes in handy. So going back to the problem we were on, so once we've combined like terms, we can go ahead and drag out that 2 over, or that 2 over there, and we'll have 2 times the integral of x to the 5th. So now from here we can go on back to the basic power rule, and this just gets us 2 times x to the 6th over 6, which is just 1/3 x to the 6th. Now we can take the derivative of this, which would get us, well, 6 over thirds x to the 5th, which is just 2x to the 5th. So once again, this goes to just prove that this holds true as well. The integral of f of x times g of x is not equal to the integral of f of x times the integral of g of x. So these are 2 very basic integral rules that should be established early on, and these will come in handy in a lot of future integral problems. So in the next video, we're going to start going into integrals, but with trigonometry or trigonometric functions. So we'll first kind of write out some integrals in using trigonometric functions, some very basic integrals like sine of x or cosine of x. And as we go on, we'll start doing slightly more complex examples of bringing the power rule, the chain rule, and things like that into play.